G'day, thanks for watching this video on the Pickaxe Proto platform. In this video we're going to be assembling the motherboard platform, and I'll quickly go through a bit of soldering to show you how that's done. So you're going to need a couple of tools. We've got some pointy nose pliers, side cutters, a component bending tool, a little steady hand or some sort of a vise. This is one of the panel vices. To hold the board will be handy but not necessary. Some glasses and a soldering iron is what you're going to need. So in the first one I'll do a bit of a demo on how I solder as well and how I cut the leads, and then in any following videos I'll just leave that up to you. So first off, we can open up our kit and have a look at what's inside. Alright, save the bag for later. So we've got the battery box, we've got a 20 pin socket but only a 14 pin Pickaxe microcontroller. That's because the board can hold the 08 range, the 14 and the 20M2 range, so any in the 8, 14 or 20 pin Pickaxe microcontrollers can be programmed on this board. Got some little header pins, the download socket, the stereo download socket, diode, some resistors. So we've got 330 ohms in the pack together, and then we've got a 10k and a 22k resistor, and a green LED and a red LED, and just a little filter cap for C1. Notice that you don't get a switch in the little kit. That's because when I supply the battery box like this, it's got a switch on it, so there's no point in putting two switches on it. The switch is mostly there if you're using a wall power supply rather than the little battery box. So we're going to start off with the resistors, so we'll just move everything else out of the way. Alright, and obviously this is going to be the top of the board with the silk screen, and the bottom has the bigger pads on the bottom of it. So we'll start with the 330 ohm resistors together. With this component bending tool, it's pretty good because you've got sort of 4 spaces that you can bend 4 resistors at once on this style, but if you don't, you can split them apart first. I always use this second step on these resistors, component bending tool. I'm not sure what the measurement is, but I always use that second step. Put my thumb on top and bend both of the leads over. Then use a pair of side cutters and cut that paper off. And then you should just be able to drop those resistors straight down. The 330s are going to go into R3 and R4, so I'll drop that straight into R3. And I like to have my colour bands facing in one direction. I don't care whether that's up or down, but if I've got lots of resistors that are in the same orientation, I always have the coloured bands in the same direction. So those two are in. I'll just do 2 for a start, and then I'll flip it over and solder it, and then we'll go ahead and solder the rest of them. So with my finger on the board, what I like to do is I tip the board over with your finger on the back of that resistor, and I'm going to use a technique that is called semi-clinching, and that's bending the leads out at 45 degrees and then cutting them off before we actually solder them. It's up to you and your teacher or whoever's telling you how to put this board together, but my students semi-clinch the leads and then solder them. So that's bending it out to 45 degrees by grabbing it with the pointy nose pliers. So I grab the end of the lead, and with my finger on the back so that the resistor can't move, I pull it out and actually sort of stress the lead right down the corner, right where it comes out of the pad. If you just bend it over with your finger like that slowly, the radius of that bend isn't sharp enough and the resistor will fall out when we cut it. So from up straight, I grab onto the end of it and actually pull out a little bit so that there's a nice bit of pressure, and have a nice clean 45 degree bend there. Do the same with this resistor lead. Then with my side cutters, and this is the important part, you can't just cut these leads off flat obviously because the resistor will fall out. At this point in time, lots of people do start soldering it together, but I find it much quicker if I cut them first and then solder. I'll just bring this up to close to the camera and see if I can focus on it. There we go. So you can see the leads are bent out there, and now this is when it's important to have your safety glasses on, because these leads are going to flick around. I bring the side cutters in so that they're 45 degrees to the board or perpendicular to the lead, and they should be touching on the further side of the pad, so the point of the side cutters touch on the further side of the pad. And I come in there a bit like that and trim that off. Now, if my side cutters were touching on the further side of the pad and at 90 degrees to the lead, you end up with about maybe a millimetre of lead left there, and that's just enough so that you'll get a nice joint, but the resistor won't fall out before I get a chance to solder it. So cut that one off as well. Same thing here. One there. I keep on spinning the board, so I've always got my side cutters in the same direction, and you can see, well, it's a bit hard to see with the camera, but I'll just try one more time to focus that, and you can see just those leads sticking out a tiny bit there. So I'll come back down to the table, and at this point in time we're ready to start doing a bit of soldering. A fume extractor is a good idea to keep the fumes away. You don't want to be inhaling those fumes, so if you've got a fume extractor you can turn that on now. Otherwise, some sort of fan just to blow the air away from your face is probably a good start. When you first get your soldering on, it's going to be quite a dull looking tip. It's almost a blacky colour, so the first thing I do when I start soldering is I melt a bit of solder onto the end of the tip, and again being careful that we're not breathing those fumes, and then use a scour or a wet sponge, whatever system you use, to clean that up until it's sort of a nice shiny colour. I might just do that again. So I call that tinning the end of the soldering iron, the tip, and again cleaning that up so we have a nice shiny tip that doesn't have any sort of contaminated material on it. I'll just bring my fan over a little bit more. Sorry about the noise of the fan, but will keep me healthy. So back to my board now. I've got those two resistors, so I'm going to put it in this vise. You don't need to, you could just put it on the table, but I'll put it in this vise. So just undo that and slide that down. There we go. And then I bring the soldering iron in first and touch the side of the pad. I bring the solder into the opposite side of the pad, and I actually touch the pad, not the end of the soldering iron. And make sure that you bring the solder back out of the joint before you take the soldering iron out. So we'll go 1, 2, 3, 4. Again, 1, 2, 3, 4. 1, 2, 3, 4, and this one, 1, 2, 3, 4. And we should have some nice looking joints there. I'll just try to focus the camera on that one. Doesn't quite focus. So there we go. Our joints are sort of, they come up to the lead, but they don't look like a bubble. But I can still see the lead is actually there to the end of the joint. That's the feature that you want to look for. You want them to be nice and shiny, you don't want them to be dull. And yeah, you don't want them to be a big blob over the top, otherwise you won't be able to tell whether the lead actually came through the board or whether it's just gone through the end of the hole here. So we'll continue putting all the resistors in first. So the 10K, bend it down, chop those 2 bits of paper off. 10k goes in the R2, and you should just be able to drop it and it falls in. Semi-clinch. And I do all the resistors now, and maybe even the diode as well before we start soldering. So R2 down there. I did say I'd face all the colours the same way, so I'll just spin that around so that the colour codes are all facing the same direction. And I actually, if I was doing this myself, I would have semi-clinched all of the resistor leads and then trimmed them all back all at the same time. But that sometimes gets a bit messy. Now with the diode, the polarity is important, so I'll bring that up and see if we can quickly focus. On the diode we've got a silver band on one end, and then just a black section on the other. On the silk screen there's a little white line. Now that white line lines up with the silver strip, so the diode needs to go in this direction. Like so. Drop that down. Same thing with the diode, semi-clinch that one. And all of those joints that have got something coming out of them, I can solder each of them as well. Okay, I think I've got them all there. Yep. Alright, so your board should look like that. All of these resistors should be nice and neat, close to the board, and obviously shouldn't be wobbling around. They should be nice and secure there. At this point we might start putting the IC socket in. So that's this one. I tend to work with my boards with components that are the least value first and work up, so that if I make a mistake and have to throw the whole board out, I have to throw out the least expensive components rather than the expensive ones. And also, if you don't have a vise, I tend to work from lowest to highest component height, so that I could have that board flat on the table and maybe put my finger on it and solder all the joints, rather than have the LEDs holding the board up and not be able to have it sitting level or flat. So IC socket now. Now this does have not a polarity so much, but has a little notch that makes sure that you put it in the right orientation. So at the very top of the socket there is, we've got that in focus now, a little notch, and on the silk screen there's a notch as well. Obviously that goes towards the top, and those pins should just drop in if they haven't been bent, but otherwise just carefully bend them back. Same thing, I put my hand on the bottom of them so it can't drop out, and while I've got it up against the board nice and close, I bend over with my component bending tool or a fingernail or with the pliers, doesn't really matter. Just bend over 2 of the leads diagonally opposite each other over, so that bottom corner and this top corner, just bend over those 2, so now the socket can't fall out even when I'm not holding onto it. And what I'll do is I just put it back in the vise there, just solder that one pin, and I just put my finger back on the bottom just to make sure it was all the way up against the board, and do the diagonally opposite one, so solder that one, and put my finger back on the board just to make sure it's all the way down so it looks nice and neat, and then I can just go down and solder each of those pins, making sure I get enough solder on each pad that it's a secure connection and there's not a bubble. Just go back and do a bit more on that one. They all look pretty good. Every so often, still cleaning up our soldering iron so that there's no contaminants on the end of it that are stopping it from heating up the pad. So we've got the socket on there. I think we'll go for the capacitor now. Now this isn't a polarized capacitor, so it can go in any orientation. Doesn't really matter, but maybe you'd have the numbers sort of facing left to right, so it's easy to read if you're trying to read the value off of it. Drop that into C1, finger on the back, bend the leads over, snip them off. And I'll put a few more things in so I can solder a few at once. Put the red LED into LED 1, and now this does have a polarity as well, so that's important. Bring that up nice and close, and you can see that one of the legs is longer on the LED than the other. There's also a little positive symbol in here, so the positive symbol is the longer leg, so positive lead is the longer leg of the LED, and that's obviously going to go in this hole. There's also a little telltale feature because there's a flat spot on that circle, and there's also a flat spot on the LED, which is probably hard to show you on the camera until it's actually in that hole. So I go in here, drop it all the way down to the board, all the way under. Oh sorry, all the way, don't sit it up like that because we're going to be stacking things on top, so all the way down to the bottom of the board, and bend those leads out, semi-clinching them the same as usual. I've lost my green LED, here it is. This one just goes in the different direction on this version of the board. Bend that out, just making sure the positive lead went into the positive side, and snip them off like usual. Again, some people's preference is to solder it before they cut it. One of the reasons I don't do that is I think it's faster to solder it all together, and it's easier to snip off while it hasn't been soldered. But also, the flux coating around the edge of the solder joint protects the joint from corroding, and if you're snipping off that flux coating after you've soldered it, the board's potentially not going to last as long, as it might rust or deteriorate in some way because the joint can oxidise or something like that. May as well put this socket in at the same time. So the socket has 5 metallic pins, and some little plastic support pins as well that all go in, and that one we don't need to chop any of the leads, we just drop that into the socket and push it all the way down, and that won't come out until we've soldered it anyway. So I've got the capacitor here. LEDs. Sometimes with the LEDs it's a good idea just to do one side and then heat that joint back up. Just make sure it was all the way down and touching the board. I might just go back and make sure those two are touching as well. And then the socket here. Now there's a wire or a wire between those two pads, so it doesn't matter if those two have a join between them, and same as these two, they should be joined. So you can put the soldering iron in the middle and just solder the whole lot at the same time. And need to do this one as well. You don't need to do those 5 pins because they're just plastic. Alright, now we're up to putting these female headers on. A really good idea is to get a board that someone's already soldered, or you know, if you're making the starter platform at the same time, maybe just put these male headers into those holes just so that it can support those. These female headers, you'll notice the pins are really quite thin on them, so they tend to flex a little bit. Now if they're flexed out a bit to the side, you're not going to be able to stack boards on top of it very easily. So what I'd recommend is that you have a spare board or one of the prototyping boards or something with the same pin out, and you can put that in while you're soldering it to make sure it's going to be in the right place. I'm only using 5-way female headers at the moment, but there's 6 here. That's just because these are excess stock from the electronic supplier I use, and it's much cheaper for me to use them. But in the future I'm hoping to use 6-way female headers. So for now we just need to be putting the 5-pin ones all the way to the top of that header row. Same as this one, to the top, and then the 10, and then the 10. You can do them all at the same time. There's no need to bend these leads out of the header rows. I just put one of these plates on top, whatever, it doesn't matter what one it is, but put it on top, sandwich it in there, so now they can't move, they're in the right direction, and then clamp that starter platform or whatever platform you decide to use to help solder it into the vise, so that this one's just sitting on top and it's not going to fall away. Then get your solder, and I just do one leg on each of those, and I take it out and check it just to make sure there's no gaps underneath along the side of the board there. Oh, see, that's a problem. So that was lucky that I just did one to test. So I'll take that back out and bend that over, push that in. Okay, I'm going to have to just heat up that joint again so that this can move and come all the way to the bottom of the board. And there we go. I have solved a problem. Unfortunately, did take it out to check before I did 10 of them. If you do 10 of them, it's going to be pretty hard to move them, but just to melt one of the solder joints at a time and realign it is pretty easy. So put it back in my vise again. And it's quite quick to put all these solder joints on. I just did one I didn't need to do. I shouldn't have done that one, but it doesn't matter. I'm running out of solder. There we go, clean up that soldering iron tip, and that's soldered in place now. It's nice and secure. Last thing I need to do, well two more things I need to do, is I need to put, because we're not using a switch, I need to put a jumper wire between the two sides of that switch so that the board's getting power. So just use any of these little leads that we cut off before, and just straighten that out and put a kink in it. Measure how far across it is, put another bend in it, drop that all the way down, and bend those two out like usual, cut them off. And I only need to solder the outside too. Alternatively, if you don't have a jumper, you can just put a big blob of solder between those two joints on the end, and that will also connect the circuit. Now we don't have batteries in here at the moment. That's a good thing that we don't have batteries. Put the two leads of the battery case up through the hole first, and that hole just stops it from stressing the actual solder joints, which will make that those wires last a bit longer rather than snapping off at the ends there. So put the black down in the black hole, which is negative, the red down in the red hole, which is obviously positive. Pull it down a little bit just to solder them in place. So make sure you've got the two leads poking out before you start soldering it. And solder one and the other. wires are the only thing that I don't cut first, so any wire I solder in place because it's a bit hard to semi-clinch, and then cut it off afterwards. And once I've soldered it in place, I can just pull those two leads all the way down so they're nice and flat, and that hole there takes the stress of me tugging on that lead rather than those two joints, which is good. Finally, our little 14-pin microcontroller, we'll take that out. This foam is a conductive foam, so it's probably good to keep that in case you're dealing with any other microcontrollers or anything. Good spot to keep some little i8s or whatever microcontrollers you use, so it doesn't develop static in a bag or something like that. And just need to drop that microcontroller into the top 14 pins of that socket. If you're using a 20, it would go all the way down, and if you're using an 8, it needs to be the top 8 pins. So it needs to be closest to the capacitor as possible, and making sure that notch, like in the socket, just wait for that to focus for a second, just like the socket, there's the notch right at the top of the pickaxe chip, and I need to just push that one more pin up. Sometimes you'll find the legs of the pickaxe need to be bent a little bit, and I just put them on the table and roll it up all at the same time so that it fits in the socket. Make sure that all the leads look like they're going in nice and neatly, and then you can apply a bit of pressure on that, and that should push all the way down into that socket. If you need to take that out, I just use some pointy-nose pliers or something to sort of get under there and lever it out, and try and get it all out at the same time rather than bending it up. And be careful using your fingers, because they're quite sharp, those legs, and they can go through your thumb, which could hurt. So push that down, and our board's pretty close to being done. Last thing that we're going to do is we'll grab 3 batteries, and put them in the battery box, being careful of polarity. Put that cover on and switch it on. Now I found even before we program it, that green light starts flashing with the newer 14M chips, and that's because Pickaxe have pre-programmed them to be sending a serial message out to the computer saying this is a 14M2 or something like that, so that's why that's flashing. But we can, that's ready to do a bit of a test code on, and we can start having a look at soldering together the starter platform. Only thing that I would recommend is grabbing a hot glue gun and just gluing underneath this board, so putting a bit of glue on the bottom of that board and attaching it like this one, so it's one sort of unit altogether, around like that, so that the programming jack is facing in the opposite direction than the switch, so it's easy to access that. That's all. Thanks for watching.